So welcome again to the OSPF configuration part 4. In this part 4, we are almost done with OSPF. So in the first session, in the first part, we saw how what the lab means, the OSPF meaning, and some basic information though about the OSPF. The second part, we saw how to put the configurations, how to configure the IP addresses, and some cool stuff, the descriptions, and some stuff which were very cool. And on the third part, we saw how to configure OSPF. So we configured OSPF on all routers. Some features we saw also we configured cost based on the bandwidth difference and some stuffs. And now let's come to part 4. In the part 4 is now to achieve reachabilities between PC1 and the internet. Also, reachability may be between PC1 to the FTP server. That's one of the very target. That's one of our target in this lab. So our target is to achieve that PC1 has to ping router. I mean the internet has to ping the internet. So how are we going to achieve that? First of things, you should understand how router works. Router forward traffic that the routes is existing in the routing table. So router will not forward packet which is not the route which is not existing in the routing table. So let's go direct to PC1 and see if we can see the network from Google, from the internet. Go to the Paris router. You see we have a lot of packets was exchanged here. Let me clear the screen and get this one. And then go to the display IP routing table. So after displaying the IP routing table, you see now we have direct routes and we have our OSPF routes where we are arranged. So let's dig one by one. So let's go protocol, then say direct. So here these are only all direct routes that are arranged by router via directs. What does direct means? It's direct because the routes are direct connected on the router. As you can see here, the network 10.10.10.0 is direct connected to the router. You see, it's not lent via the routing protocol. And then you see the preference of it is 0 and the cost is 0 because it's locally exists on the router. And the next hop of this one, whenever the router receives the packet that is destined to this network, it will forward direct to this interface, which is Ethernet 401. And that's the next hop IP address. So, but also the Paris router lent some of the routes via OSPF, the beautiful protocol that we have ever seen so far. So we learned some of the routes, example 50.8, 20. All of these routes were learned by OSPF. You see, the cost of this one is 200. To reach this one is 200. Why is 200? Because this is a network 50.0. So it's 200 because the interface that are connected are gigabit. The interface that are connected are gigabit. You see here, giga Ethernet. So the cost of here will just be 100,000 divided by 1,000, you get 100. That's why you see the interface, the cost between this Paris to this network, it's just 100 plus 100 here, you get 200. 200. That's why you see here the 200. 300. I mean 200 for the 8. You see this also the 8 is 200 because it's 2 hop located from the Paris. But for 20 is basically located here. You see it's just be a 100, 200. I mean it's plus 1,000. It will be 1,200 cost. That's the total cost of that one. So you see now we don't have any route that is related to 8888 in our IP routing table. You can go direct and say IP routing table, then put the network that you need to check if it existing. Now you see the routing table saying that I don't have any route. I don't know any route that is 8888. What is this route? So first you need to understand, if you don't receive any route that is 888, you should understand that the problem is basically to the router that network existing. So for this network, because I don't get this network from here, and I'm expecting that this router was advertise this network to all other peers via OSPF. That means this network is not visible at Tokyo. So let's go direct and see how we can make sure we advertise this OSPF, this network 888 to the network. So go to the Tokyo router, and the Tokyo router, let's see if this one was advertised on the OSPF view. You see now, oh, we have only two network, which is 0 and 16. So we don't have any network which is 888. So for that to work, just go direct and add this network under the OSPF view in the OSPF area, so that that network, that network to be advertised to all other neighbors. You see, now go add another line here, which is 8888. But now the Udican mask will be very 255 255, as you know, because we have 24 is our subnet mask. Okay, sorry, I didn't put here, but it's 24 subnet mask. So if you have 8-bit, which is for host, when you flip those bits to ones and then you convert it to decimal, that's what we get. So after this command, now the OSPF will advertise this network to all other peers, to all of its neighbors. As we can see here, the neighbors, we have two neighbors, 333 and the 555. So you see now the network will be advertised to this peer, also to this peer. The same applies to this one. We will receive this route and advertise to its own peers. Also, so these routes will calculate the routes to the network when it was learned via the OSPF. So let's go to Paris again, Paris router, and try the same command that we wrote previously, if it works now, because I've already advertised the network in the OSPF domain. So I'm expecting that Tokyo router now advertise the networks to all other peers. So all other peers should get the networks. Now go direct and light the command. You know, you see the output came. So it said that the network 8880/24 was learned by OSPF. The preference is 100 and the cost is 300. Why 300? Because the network is just located beyond beyond Tokyo. You see, it's a network beyond Tokyo router. So the total cost will be just the cost of the is a summation of the cost of the individual interface cost. Example here, it's 000, 001, and here it's 001. So the cost will be 0, 100 plus 100 plus 100 here. It's 300. So now whenever I'm trying to reach server, which is 888, now Tokyo router understand this network. Tokyo router, it's very cool. It's very cool. Display IP routing table, protocol, and say dialect. So you see now, Tokyo router understand this network as it's direct connected. So whenever it receives the request that goes to any network, any IP in this network, it will forward that packet to next hop, which is 88881. You see, this is how it works. So when you come to, the Paris network, the Paris here, then go to my computer, my beautiful computer here, which having this network. First, before anything, let's try to ping if I can reach gateway, because I can't access internet if I'm not able to reach gateway. So is gateway available? Is gateway pingable? Okay, 10, it's 1, right? Okay, now boom, you see, now I can reach gateway. I can reach .1, which is IP address of the gateway in this network. So what about 888, which is Google? Is it pingable? Okay, go and ping 8.8.8.8. Boom. You see, it's request time out, request time out, request time out, request time out. Okay, you see now we have problem here. The results, it says request timeout, but here on the Paris node, I can see I know the network 888024. I know the network. What will be the problem? Okay, let's go to Tokyo router and see what is missing at Tokyo router. So on the Tokyo router, we can display IP routing table and try to check the network, which is 10, 0. Is this network exists? No, there is no network like this in the routing table, because for this router to return the feedback to the network, which is 10 it has to understand where this network is connected, where this network found. So without advertising this network to the router of Paris so that it can be advertised to all other peers, that means this network is not reachable. It's not visible beyond Paris router. In the Paris router, this network is direct connected. You see, in the Paris router, this network is direct connected. But for the beyond Paris network, this network is not known. So what you should do is enter to the Paris network, and then under OSPF view, under area view, advertise that network. That network which is 10 0 / 255. You see, now this is how we can configure. Now you see, I've already advertised the network to the OSPF, so I'm expecting that this router, Paris router, advertise that network to all other peers in the network. So let's go direct to Paris. Wow, let's go direct to Tokyo router, and then I'll write the same command that you wrote before and see if we can receive the route. Now the route is visible because it was learned by OSPF, and this is a cost, the total cost of it. So the total cost, why 1,000? Why 1,000? You can see why this network is known via 1,200, and the next stop is .1. You see here, the interface of here is one. The interface here is one. It's 1,000. Yeah, because you see the interface between PC1 and the Paris, it's Ethernet. That means it's 1,000. So the total cost will be the cost of this interface, 200 plus 1,000, which is 200. 1,200. That's the total cost of that one. So can we repeat the same command at PC1 to see if we can reach now Google? The internet. Is it coming up? Why? Why is it known? Why is it known? Why the feedback? Okay, can we try to ping the gateway itself? Okay, the gateway it's visible, right? You see the gateway. The gateway is visible. 111 is visible, but 888 also it's not visible. What's the problem? Okay, that's cool. That means if I'm able to reach here, but I'm not able to reach here, you see, I'm not able to reach here. So you see now here I just put the router because I don't have any ways to configure the internet. This internet is not configurable. I cannot perform any static route here or whatever. Whatever static routing. So what you should do is to configure the server as the internet. So under this, you can say the system name of this one. Let's say it's server, and the interface that is connected Ziga 000, and the IP address of it is, it is 8.8.8.8.24. Okay, now it's okay. Let's say descriptions, link, to where that router, it's Tokyo router. Tokyo, and after that, let's configure default route. So whenever the request coming, so this router will just forward to the next hop, which is connected to which IP. It's 1.1. Okay, it's 8.8.8.1. It's the network of the. Okay, here I forgot to put more 0. Now display IP. Okay, when you check this one, I've already configured the return back way. Let's check the reachability. If I can reach the gateway, unknown host. Okay, it's long IP. Sorry, it's long IP. Now, okay, it's now reachable. Okay, now I'm good with this one, right? I'm good with this one. So let me turn back my internet like here, and let's go again to this server. Now let's try again to ping. When you ping again 188.8, it's reachable because this router understands where this network exists. And when the request come to Google, Google will return the request to static. If you don't know what is static root, you can just check me directs, and I'll tell you. Maybe I can show you what is this exists, or I can get time. I'll explain to you what is static root on this on this a beautiful session. So that's why, that's the first thing that we've completed on this one. But what if I need to ping by using word called, they say, it's google.com. Is it possible? Is it possible? Is this computer able to translate the host name to IP address? Because all our servers in the network, they are known by IP address. Is it possible for this one to translate words to, the host name to IP address? That means this you need to enable DNSF. The DNS, domain server resolutions, domain name resolutions. So if you will enable DNS, then the computer will be able to translate words to to IP address, and you can be able to reach. So let me try to configure the static DNS. So static DNS, how is it configured? Go to the system view, then say host, then IP. Is this okay? I know, I think it's IP, then host, then you put the host name. I can say it's google.com. Then let's add another IP, which is 8.8.8. Now I've already I've assigned I've configured one of the static DNS. That means I'm telling the router, if you receive any request that is saying it's Google in its packet, there is a Google as a destination, then you have to translate it to 8. So the request should be configured. It should be sent to 8. So can I go back to this computer and try the same command? Okay. Now it's say host google.com unreachable. Okay. Okay. So I think because I don't have, okay, it has to work. Why is this not working here? It needs to be configured. Okay, that's cool. It is not visible via this computer, maybe because it's simulation. But let's try here on the router. Let's try here straight on the router. So here on the router, we can just try to ping 8.8.8 direct, which is the internet. You see now it's internet. But also, what if I wrote google.com? Will it reply? You see now it's replying, because it says that we have already configured static DNS, and the DNS will translate google.com to this IP address. That's how we can configure this beautiful lab. So moreover, let me try to integrate this FTP server to the network. So for me to access FTP server, I should be able to receive the network of the FTP server to Paris. So can I receive this network? Let me check the IP routing table of it and then display the network, which is 172. 172, it's set 1.0 and it is 100. Is it reachable? This network available? Now it says Paris. We don't have this network. If we don't have this network, what would be the problem? So that means I'm not receiving any network distinct to 172.1.10 by any protocol. There is no any protocol that is advertising this network. So possibly the problem will be at Nairobi. So let's go to Nairobi and let's try to check the OSPF configuration. So let's go to Nairobi and go straight to the OSPF configuration and see if we have OSPF advertise the network. So now you see we have only this network. So this network was not advertised. So let's go dialect and assign and okay. Oh, sorry, I've configured bad. I've add another area. Undo that area because it will confuse us. Okay, display this. Now it's removed. Then go direct to area 0. Okay, and then advertise the network use 172. I mean, it will be 16, 100. Okay, it's set 1, not 16. 31, 100, and no, it is 31. Okay, 31, 0, 0. Slash it. Okay, the we can mask 255. Now boom. Now you see, we have already advertised the network. Where is it? Okay, this one here. So the network is already advertised. So let's go to Paris and see on the Paris nodes, on the Paris router. Am I receiving the network? Now you see the network is received and it has a cost of 300. How 300? Because you see the network is advertised, that is found beyond I mean what? It's beyond Nairobi. So you see here the interface cost of this one, it's 100. This is also 100. Now this one is 100. That's why the cost is 300, because it's a mention of the individual costs along the path. You see. Now, can I able to can I reach this one? Can I ping? Can I ping this one? Let's try to, if we can ping the server, which is 172, 31, 0, 100. You see. Okay, now request timeout. Now it's pingable. Now you see, it's pingable. Now I can reach from PC1. Now I can access FTP server. Can I log into FTP? So how to log into the FTP? You just need to write the command FTP. Then you put the network. The IP address of the network with 100. Okay, invalid command, because the PC, it's a simulation, right? The PC is not recognizing that command, but I can accomplish that using the Paris router, because now you see in the Paris router I can able to ping the network address. You see, if I'm able to ping, can I FTP to the server? Can I FTP to the server? Now let's FTP to the server by starting command FTP 310100. Now, okay, it's saying that the error failed to connect to the remote server. Why is failing to connect to the remote server? Is it wrongly configured? Okay. Okay. Okay, it's not FTP. It has to be FTP. Okay, let's go take a look on the FTP configurations. It's 310100. It's 310100. Okay. You see now the server was off. Oh, was off. Server was off. Okay, let's start again. The server. Let's start the server. Okay, start the FTP now it is listening. Now you see, when I was trying to FTP, the server was almost off. The IP address was reachable, but the FTP service was off. Okay, let's go again, then FTP. If FTP, you see now it's asking for the username and the password, but for me, I don't have any username and the password. You can go direct and try the FTP configurations. When you try to say directories, you will see we have one file called the test file. Oh, this is cool. So I've successfully logged into the server. And in the server, we have this file which goes to testify. So from here, from the Paris router, now I'm able to download and upload. Okay, let me delete this one. I'm able to download and upload this file. So how can I download this one? They say it's get. You just get this one and then copy the file name and paste. Okay, it says that the file is not existing, connect closed. Okay, let me try again. Okay, it's not existing, close file. Okay, it's okay. Let me try to put. Can I try to put first go to my directory and say, let's check. Let me try to put this configuration file here. Copy, then go to the bureau of commands, FTP to the server, enter, then put one of my favorite files to the server. Now you say the transfer finished successfully, data is crossed. Now you see the file is transmitted successfully. So you can see, you can check the directory and you see now it's 2 files added. One was uploaded by the Paris router to the FTP. So when you go to the FTP server, now try to refresh. Okay. Now, now let's try to refresh. Okay, let's go to lab. Yeah, now you see the file is uploaded successfully. So that's why that's how we can configure the FTP server and some stuffs. So that's best part of our course. Now we saw how we can integrate internet, how we can integrate FTP server, and the last part of this lab is to configure these stations now to access FTP server. So I'm going to show you how you can integrate stations, wireless configurations in a very beautiful lab here. And at last, so we just remain with one part, which is the last part. Okay, thank you for listening me. I hope you've enjoyed checking my videos. Don't forget to subscribe. So I'll be sharing more important important topic and important things. You can just stay tuned. Good things are coming. Thank you.